everyone, in this video I want to talk about how to find the Taylor series for f of x equals 1 over x cubed at c equals 1. Now I've written down the formula for Taylor series here. So in general, f of x equals f evaluated at c times x minus c to the 0th power all over 0 factorial. And then the same sort of expression, but instead of zeros, I've got 1. So I've got the first derivative, I've got x minus c to the 1st power, and 1 factorial, and then plus everything with 2's, plus everything with 3's. So once you know the pattern, it's very easy to remember this formula. And notice that I have the 3 dots, the ellipses on the end, which means this goes on forever. So if I were to spend an infinite amount of time and compute the infinitely many terms for this series, I would have an exact formula for f of x. Now, normally we can't do that. So I'm only going to do a Taylor series approximation in this video. Maybe I'll do the first 2 terms or the first 3 terms. And that's very important that you include the approximation symbol when you find the Taylor series approximation. So let's take a look at how we do this. I recommend setting up a table. If you don't do the table, it's very easy to make a mistake, a thinko, or a typo. So definitely make your table. That's going to help keep everything really well organized. In the first column of my table, I'm just going to write f of x. So that's a copy paste for me. That's x to the negative 3. And then I'm going to do a few derivatives. The first derivative is negative 3, x to the negative 4. Second derivative, power rule again. I'm going to have a positive 12, x to the negative 5. And let's do one more for fun. We'll do the third derivative. And now we've got negative 60, x to the negative 6. Okay, in the second column of my table, I'm going to evaluate each of those expressions at c. And in my example here, c equals 1. So I'm going to do f of 1. So 1 to the negative 3 is just 1. The first derivative evaluated at 1 is just going to be negative 3. Okay, these aren't too bad. Second derivative evaluated at 1, that's a 12. And the third derivative evaluated at 1 is negative 60. So now I'm pretty much done. All I have to do is go in my Taylor series formula, and I have all those little values for the derivatives evaluated at c. And then I just need to copy paste essentially x minus 1 to the 0, x minus 1 to the 1, etc. So really the hard part is done. So I'm going to say f of x is approximately, because I'm only doing the first few terms here. So f of c, f of 1 is 1, times x minus c, which is 1, to the 0th power all over 0 factorial, plus f prime of c, so that was a negative 3, x minus 1 to the 1st all over 1 factorial. Let's keep going. I've got 12 x minus 1 squared over 2 factorial. And lastly, a negative 60 x minus 1 cubed over 3 factorial. Now let's clean this up a little bit. So I'm going to come up here. F of x is approximately, the first term is just 1. Next, I've got a negative 3 times x minus 1 plus, now 12 over 2 factorial just gives me 6. And then I've got negative 60 over 3 factorial, so that's negative 60 over 6. That's going to give me a negative 10 times x minus 1 cubed. And that's it. Now, I know this is only approximation. It's pretty crude. It's not going to be perfect, especially as I drive away from c equals 1. It's going to get worse and worse. But, you know, for values close to c equals 1, I've got a pretty good approximation for my function. And so here would be my final answer.